Okay, good evening, everyone. Let's start for today's session. Today, the PWM technique, which is known as space vector PWM. But simple PWM technique is no used to switch the to give the pulse to the switches which when used in converter and inverter. Simply, you know about the converter. The very simple. Suppose a buck converter. Is Q. Q need the pulses. And how you generate the pulses to give the microcontroller the circuit. because of the pulses required, it is in kilohertz, very high frequency. It may be 5 to 100 kilohertz. Sometimes it will be greater than 100 kilohertz also. It's simple, if you observe the circuit, you know about this one. Output voltage is duty cycle times of input voltage. But you require that duty cycle, it will be operated at a frequency of 100 kilohertz or 10 kilohertz, 20 kilohertz, or some 50 kilohertz, like that. In in an inverter, there is a very low frequency is used, like low, sorry, not a very low. It will be 5 to 10 to 20 kilohertz. But in converter, DC converter, it will use more than 20 kilohertz also. Sometimes 100 kilohertz, 200 kilohertz, and a very low amount of power is there. Then it will also have 500 kilohertz. Then how generate this type of frequency? Then you know about the simple PWM technique. There is a reference signal. VR is a reference signal. Then we require carrier signal. This will be a carrier signal. Then this carrier signal have a frequency of in kilohertz, and this is a V reference generated the reference signal. Then duty cycle, no duty cycle, where the this V reference is, if VR greater than VC, the carrier signal. If you take this one, then you will know there is a duty cycle generated. The remaining time is 0. Then it will again a duty cycle. In this condition, you know this one is the on time, and this one is the off time. This is the simple circuit for a converter. Sometimes we also used triangular wave, but in a DC converter, triangular I avoid it because of the frequency and shifting. Then it may be vary the frequency in triangular wave because of the reference signal and carrier wave. Suppose if you use same thing, uh, it's a sawtooth, in place of sawtooth wave, if you use carrier wave like that, then on time have this one and this one, both are on time. Then here is almost total on time. Then this will be off time. This will be the off time, on, then again on, again on. This one off time. The same thing, suppose if you change the reference, then what happens? If you give here, goes to here, then you can observe there is a changes in frequency also. If you take, this is the not mandatory, you don't know where is the frequency is there. If you take again the signal is starting, then if you suppose if you trigger the hair, and what happens in this thing, you can observe this is the on time and total off time. This is the on time. This is the here it will be okay. But in a closed loop system, the reference signal sometime is varies like that, or like that. It varies sometime. In this condition, you can observe the frequency is also change, because of it will take it more time. Sorry for that. Simply you can observe only this time and this time is different thing. Same thing here, this time and this time is different. In this it can be taken the more time, or you can change the uh, time period of the carrier in transient condition. That's why they are used in use of sawtooth wave in converter. This is the converter type where the reference signal is fixed, because it will be fixed. We started from here only. It will depending on the on time and off time. Frequency will be fixed here. Okay. This is a simple PWM technique. Here is our reference signal and our carrier signal. It will compare. If a reference signal is greater than the carrier signal, then it will give the on a comparator. And if a carrier signal is less than the reference signal, then it will give off. It means 1 or 0, like that. Second one is come the sinusoidal PWM. In the sinusoidal PWM, same thing, reference signal is changed by a sinusoidal system, which one is in inverter. There is a, so it will define the frequency of output voltage. Which one you want? Like if you want a 50 hertz, then you gives the 50 hertz of reference signal of sinusoidal. Then output voltage you will get the 50 hertz frequency. And this is the carrier signal. It may be from 0 or it will get to negative also, because of the sinusoidal is positive negative both side. In this condition, same thing, if this one is a high, then pulses go to output. If in time is 0, then this will be the pulses, again this one, like that. Same thing positive side also, pulses is there, and here is pulses when VR is greater than the carrier signal, like that. In the board condition, switches given to the another switches. If this one is the S1 and S2, it was in single phase, then this will be S3 and S4, like that. Then same output which comes also. When voltage turn off, and this will be negative. It will be from your circuit, how design the circuit to make a sinusoidal. This will be very. This was the long duration. That's why it like that signal. Sinusoidal. Same thing you can use. This is the sinusoidal PWM. Next one is another signal is known as the space vector modulation. This one is SPWM, sinusoidal pulse width modulation, and see this one is the simple modulation PWM, pulse width modulation. I- Next one is space vector modulation. It will mainly used for the three-phase system. There is switches is more number of switches there, and you can use this one. Store signal. Next one, let's start from here. In this, there are two reference is given. You can maybe add there also. Only compare to this one. The carrier signal is very high frequency. Then if you observe at this will be 50 hertz, and the carrier signal in kilohertz, like 5 kilohertz or 10 kilohertz. Then if you zoom this one, it will looks like a very about this will be very nearer to this to signal. Then you can, if you take only one strip of the one cycle of a PWM carrier wave, then you can get this one like that, a strip only for one period time period, because it's very high frequency. Take for one period, it will looks like that only. It will be a carrier signal like that, not a simple strip. This will be VDC voltage. And compared to this one, the different type of phases there. This will be A phase. If you take this will be R A phase, B A, B B, B C. You take this one. Suppose this will be minimum point. Second point is this one. Sorry. Oof. At every point, mark of this one. The 3 point which one cut to the reference signal. This will be at this time. This will be a VA. This time this will be a VC. So it denotes the time of this one or magnitude of this one. Because of this magnitude, you can define the time. How much time it will be on, turn on of the switches. The magnitude of this one VC. Third one is a VB. I have written this one VB. This is here. This will be VC, VA, VB, and VC. Yeah, three magnitude. You can define this one. Three magnitude. If you zoom this carrier signal, this will be a strip, simple strip of a triangular wave. And this will be looks like that. There is a one time period here. Okay. This will be the hop of that one time period. Here this will cut the magnitude of this carrier signal, then it will generate gives the high voltage, which will generate the pulses like that. How much time it will be on or off. Same thing if you cut here, it will generate the VA signal. This duration only. There are three duration: VA, VB, next only VC. So cut that, this time it will be high VA signal. Then if this will is the VB, VB cuts the hair of a carrier signal. This will generate this amount of from here to here. B portion, B phase you can say. Next one, VC. Remaining time it will be not any signal, then it will be 0. Again it will be repeated like that. If we, same thing, if we cut here, then generate another signal for a one time period. Same thing it will be reflected to. Then how decide the 0 1 0 1 pulses for ABC? ABC means it means three legs, three between them, two phases, decide the phases and on the signal. You know about this will be a three legs per three phase system. A, B, C phases. This will switch 1, 3 and 5 is there, and this will be 2, S6 and S4. Then you require the ABC voltages. This will be VA, VB and VC like that. If it is a V, if you take see this one, where is a high this signal, then this will switches on, and where there is a low signal is there, then lower switches will be on. Opposite of this one, because of this will be complementary switches. Then there is a all three will on. Suppose if all three is on, that means the voltage generated by this one will be 0. Where there is no return path, only a positive signal is made from there. That's why this will be a 0. Same thing when all of the switch off, this will be a upper signal. Then 0 it means the lower switches is turned on. This will if this one turn on, then we made the only negative, not a positive. Then this is also 0. These two condition will be can say the this is the off period of the, you can say this is a delay time also. So the off period of for this. When which one is a longer of this one, remaining time period take a T2 here, and this will be a T1, which one is lower. You can say this will be a T naught. If total 0 is a T naught, then this will be a T naught by 2. Approximate half of this one will come on the same thing again for us total time period. You can on and off the switches like that. Then how generate the time period of T8, TB, TC? Same thing. This will be a for a T8. This will be a TB. This will be TC. Then how will generate this one? It will a simple logic of triangular. We know about triangle. There is a two triangular. Same thing you can observe here. This will be triangle. One is here. This triangle, second triangle, and this will be a third triangle. And this will be TA. Take the half of this one is will be TS like that. For this one, to take this will be total. Then what happened? Same thing. If you take this is 0, the T1. Suppose this will be T2. This will be A, B like that. Then you know about the triangular rules. Yeah. Sub slope. So what is the slope? This one, y axis A minus 0 divided by of T1 minus 0. Same slope occurs for the this triangle also. Then what happens? This one B minus 0 divided by of T2 minus 0. And if you want to calculate the time T1, because of this will be T1, not a T. Total time period is Ts. Then T1 you can generate, calculate by divided by A by B and T2. But here is A is a VA, VB, VC. B is total VDC, VDC. T2 is the time period of total TS. Same thing, then you can generate TA. TA will be VA divided by total VDC into TS. It will maybe minimum, maybe maximum TA. It will depending on the uh, carrier signal where it is the cut the reference signal. Sometime T will be minimum, sometime TB will be minimum, and TB same thing, VEB divided by a VDC, and TS same thing, TC is BC divided by a VDC and TS. This is the 3 time period, you know. And T off, there is some problem in a time never will be negative. Then if you calculate this one, it will be a 0, and this is the VA, then we will be minus negative, minus of VA divided by a VDC, the time will be also my negative. But you need the positive time period, then simply add some uh, offset signal to this one for the on off. Then which one is a minimum? You can add this one, minimum time period plus offset time period. Uh, sorry, some 0 time period. This one, this time period is 0 time period, and this one also there will be a T naught by 2, T naught by 2. This one, if you calculate this time to this one, this will be negative VA. And if you want to up of this signal to add something which is known as T offset. T minimum, which one is a minimum? Minimum time also negative, then take a negative sign to make a positive, plus half of the total time off period, because of you can add only this one, not both requirement, because of the minimum is here only. Then simply add this one. If they are it will or more negative, then it will more add the more time negative also. Then simply add this one to clamp the circuit, like that, clamp the time to positive. Then you can generate the offset signal. Then what is the TA on time? Simple, add the offset time on a TA plus T offset. Same thing, TB on time, it will be TB plus T offset. Same T offset is required for only to make the positive of time, not a negative. Then you will calculate the TA, TB and T not time, TC, on off time. This is the on time, remaining time will be off. Okay, but let's start some questions. I think some questions in the previous also there. Then after we start this one. Question first related to the following ABC signals as VA, VB and VC is a 20 sine 550 pi t. Then find the value of mod alpha plus mod beta at time of 1 divided by 200. Then you should calculate first of time V alpha and V beta, then take the magnitude of this one, that one. Then after you use the omega t at place of the t, use the 1 by 200 of time. Okay. Same VA, Bm sin omega t. Delay of 120 and then VC. Then here is Vm is 20 and omega is 50 pi is given. You know about V alpha, simply V alpha is VA minus half of VB minus half of VC. You can take a common of Vm, then it will be a y sin omega t minus half of minus 2 pi by 3 minus half of a sin omega t plus 2 pi by 3. So simply open the bracket by using a sin a minus b and sin a plus b, sin a cos b, cos a sin b, like that. Then we will get the V alpha value. It will be 3 pi into Vm sin omega t. Then what is the numerical value of V alpha? Required Vm. Vm is 20. Omega. Omega is by the 50 hertz. It will be 50 pi. Then what is the T? T is given 1 by 200. Put the value here. V alpha is equal to 3 by 2 into 20 sine 50 pi into 1 by 200. 30 sine pi by 4. Sine pi by 4, it means 45 degree. Then V alpha is 30 sine 45 1 by root 2. It will be 21.21. Same thing, we should calculate the beta. We have to calculate beta. Beta will be same. VH will be 0, 3 by 2 VB minus half root 3 by 2 VC. Same thing, you can common root 3 by 2 VB into sine. Just I have written omega t minus 2 pi by 3 minus of sine omega t plus 2 pi by 3. To calculate this one by same formula. uh, Sorry, this will the Vm also. We will get the root 3 cos of omega t. Put the value of Vm and omega and t, then we get the final numerical value. Vm is 20 cos pi by 4, same omega t will be pi by 4. So it will be same value is root 1 by root 2. Then Vb is equal to same minus of 21.21. Then what is the total? We are asking the question V alpha plus V beta, but it will be given the modulation index. It means you take a mod, give mod alpha plus mod beta 21.21 plus minus 21.21. So there is a modulation, then sign is the same, positive sign will taken because of sign is represent the direction, but modulation signal is gives the magnitude only, then take a magnitude of this one. So same 21.21. So answer is 42.42. The next question, from the same question find the value of mod D and Q for angle is rho angle is given 25 pi t, and t is also given 1 by 100. Then you know about the VD and VQ. Simple, use formula. Alpha beta we have already calculated. Then VD is, then V is alpha cos rho plus V beta sin pi 2 minus rho. Same thing it will be, not, it will be a sin rho. Because of alpha beta is replaced by the 90 degree, then it will be replaced by 90 degree. This is V alpha or the Q minus V alpha sin rho plus V beta cos rho. V alpha is 3 by 2 written here. V alpha is 3 by 2 Vm sin omega t into cos rho, and V beta is minus 3 by 2 cos omega t to common, then sin omega t, sin A cos B minus cos A sin B, sin A minus B, it means sin omega t minus rho. And what is the Vm? Vm same 20 omega is given as 50 pi t in previous question. T is given 1 by 100 and rho is given as 25 pi t. Then Vd is 3 by 2 into 20 sine of omega t is 50 pi t minus 25 pi t, it will be 25 pi t, 30 sine 25 pi t. Then 25 pi t and t is equal to 1 by 100, then it will be 5 by 4, same root 2 by 1 by root 2, 30 divided by root 2, 21.21. PQ is V minus V alpha sin rho and V beta cos rho. V alpha is 3 by 2 Vm sin omega t into sin rho minus 3 by 2 beta is Vm cos omega t into cos rho. This is sin A sin V minus cos A cos V. You can opposite of this one. Sinus cos A cos V minus sin A sin V. This will be cos A plus B. But there is a negative sign in both both sides, then take a negative bar common 3 by 2 Vm. This will be sin A sin V plus cos A cos V, cos A minus V, cos omega t minus rho. Same thing, omega t minus is rho, omega t is 50 pi t or rho is 25 pi t, then 25 pi t, t is 1 by 100, then same thing is same answer. This will be cos pi by 4 is 1 by root 2. Mod of Vd plus mod of Vq is equal to 42.242. Okay. Next one, same thing. If rho is 50 pi t, then what happen? Vd and Vk. Vd is 3 by 2 Vm sin 50 pi t omega t minus rho, this will also 50 pi t, then this will be a 0. Next one, Vq minus of 3 by 2 Vm cos 50 pi t minus of 50 pi t, same thing, this will be 0, cos 0 is 1, then it will be a minus of 30, then mod of Vd plus mod of Vq, it will be a 30. Same question is asking about the select the frequencies present in Vd expression if the rho is 200 pi t. It will be same thing, use omega t 3 by 2 Vm sine omega t minus of rho, then it will be a 3 by 2 into 20 sine omega t is 50 pi t minus of 200 pi t. Bd is equal to 30 sine of minus 150 t. Sine minus theta is equal to minus of sine theta. Here omega is 150 pi, not 150 t. And omega is equal to 2 pi f. Pi cancel out. F is half of this one, 75%. Some question is related to the basic, I think. Here is given the which of the following options in circuit works for the combination of voltage and current sources, which are acceptable. There is I1, I2 is given. I1 is 1 ampere, I2 is 2 ampere, I3 is 4 ampere. Then V1, V2, V3 also given 1, 10 and 11 volt. Simply you use the KVL KCL to verify it will be correct or not. Then you can simply you will check. Let's check for the first. I1 is given 1 ampere. This will be 1 ampere. V1 V1 is 1 volt. V2 10 volt. And I2 is given 2 ampere. This is no not mentioned the current. Any current can be follow here. Resistance is also not given. Then it will be maybe resistance is decide the current. That's why it will be this circuit, this current add up, and this current also. Because current is not there, then simply use the KVL in this case. In this loop, use the KVL. Then what happens? Minus of V1 minus of V2 plus of IR is equal to 0, minus V1 minus 1 volt, V2 minus of 10 volt plus IR is equal to 0, IR is equal to 11. Because if there is not mentioned the current can be flow anything. It will depending on the resistance. If you take a 1 ohm resistance, the current will be 11 ampere. If there is a 2 ohm resistance, the 11 will be a 5.5 ampere. Then it will maybe possible case. Because there is not a violation of the rule of KCL and KCL. KCL also satisfy, KVL also satisfy depending on the resistance. Next case, I1, I2, I3. All of this is given. I1 is 1 ampere, I2 2 ampere, I3 is 4 ampere, then V1, V2. This will be a resistance. Then what happened? There is a 1 ampere current is flowing, 2 ampere, there is 4 ampere current. Then how it will possible? When this is flow the 1 ampere current. Then there is a voltage source, it can be flow the 1 ampere current, but it is depending on the V2 voltage also. And 1 volt V2 is given as 10 volt. Again, or is not mentioning, they are all of things depending on the resistance. Okay, if then it will be circuit is also possible by using a suitable resistance. Next one, third one, 1 ampere current, I1 is 1 ampere. Then V1 is also 1 volt. Sorry, I2 is this is one volt. I2 is 2 ampere. V2 is 10 volt is given, and I3 is 4 ampere. Resistance is not given, then you can choose anything, any value of resistance to satisfy this equation, this circuit. But here you can see the 1 ampere current is flow from here and 2 ampere current is flowing from here, but it is given in the bronze 4 ampere. Then how it's possible? There is a 1 ampere and there is 2 ampere. Maximum it will be 3 ampere current. Then this is to violate the rules of the KCL. Violation of the KCL is here in that node. So 1 ampere, total 3 ampere is outcome incoming current, but 4 ampere is outgoing current. That's why this will be not possible. KVL may be possible because of these are not given in the voltage drop across the current source. That's why KVL may be satisfied, but KCL is not satisfied. That's why the circuit will be wrong. Next one, circuit 4. This is also 1 volt, 1 ampere, I2 2 ampere, V3 11 volt, V2 10 volt, I3 is 4 ampere. Same thing again, violation of the KCL. Total incoming current at this node is 3 ampere, but outgoing current is 4 ampere, and this will also not possible. Okay, only these two circuit is possible, acceptable like that. Circuit 1 and circuit 2, 3, 4, not 1 and 3. 1 is possible, 3 is not possible, and this option is correct, incorrect. 1, 2 is possible, but circuit 4 is not possible. That's why it will also not correct. It will be possible. Only circuit 1 and 2 is acceptable. Okay. So a single phase grid connection for a phase set of 90 degree and gain of 1 at 48 hertz of frequency, then what is the value of A in the below transfer function? There is two transfer function is given, HS connected in cascade. Cascade connection is means the multiplication of the uh, system to system, which one is presented in the frequency domain. Same thing if in time domain, then you can't be multiply directly. Then there is another rule to multiply of two system, cascade connected to system, which is known as the convolution. You can you can learn in the signal system. I think you know about that. But here is the frequency domain system. Then frequency directive can multiply of the two system, which one presented in frequency domain known as the Laplace. Laplace or a Fourier, anything you can directly multiply of those system. Then it will be multiply of the HS B divided by S plus A. Then this will the want the 90 degree phase shift. Actually, you know about the alpha beta. Question 6, low pass filter. Yeah, you can say the low pass filter. There is a no pole. Nah, if you draw the body plot of this one, there's a sorry, there's a one pole. There's a not there's a not zero there, and there's not b divided by s plus a. There's also not pole at the origin. Then it will not start from the origin. It will take some frequency, which is frequency is a. Then after goes to 20 dB up per decade. Now this is something low pass filter, you can say, by the body pass. This is the magnitude in dB. This is the frequency in log omega. If there is a poles at origin, then what happened? This circuit start from here at the same 20 dB. Then after it goes like that, minus of 20 dB and goes to minus of 40 dB per decade slope. Okay, leave it. Then what is the need of this one? 90-degree phase shift. To know about the alpha beta transformation from ABC to alpha beta, there is a three signal A, B, and C. From this one, we can convert a three-phase system to the two-phase system known as the alpha beta system. But in single phase, there is only one phase. Then how can you shift the single phase system to the alpha beta? Two phase system, single phase system into two phase system. How can you convert this one? Because same thing, conversion of AC signal to alpha beta, three phase signal to alpha beta, then after you convert to TQ system, because of you need the reference in DC, equivalent of DC. Then single phase system also AC, then you need the to track that system, then you need the DCC, equivalent of DC system. It means you need the DQ value, VQ and VD in the voltage term. Then how can you find the alpha beta? Then after you convert alpha beta to DQ. Then for a single phase system, to find the alpha beta for a VA, then you should directly use, this is the alpha, V alpha, a single phase system, directly V alpha. For the V beta, because of the no V alpha, V beta is displaced by the 90-degree. Then simply use a phase shifter, phase shift this one by a 90-degree. Then we will get the beta. After getting the alpha beta, you can convert the DQ system. Then how chosen transfer function to convert the alpha VA voltage to the 90-degree shifting? By using capacitor, and capacitor same thing you can use. But a pure capacitor needed. Get the 90 degrees is not possible in practical. Okay, comes to the point and question. Then he has given the specification of this phase shifter, a transfer function, phase shift of 90-degree, and gain is 1. Here is required a gain of 1 and phase shift of 90-degree. Suppose this is V1, phase shift of 0-degree. Single phase system. It means if you know about this is the phase VA, then you know need a VA at phase of 90 degree. Then what is the value of HS? Then suppose think about both are the same. Simply think both are the same system. Then both are provide the same gain and same phase. And you want to multiplication of this one. 2 is here. Then you need the multiplication of both is 1 by 2 in magnitude. If there is both system is 1 by 2, then 2 is here, then this will be 1 total magnitude. It means the total magnitude you need a 1 by 2 is the total magnitude needed for the system. And there is a multiplication because of the cost condition system. Then in which case you will get the by 2 multiplication and get the half. In simple way, you know about root 2 into 1 by root 2. If a multiplication multiply 2 system, then we will get the 1 by root 2 into 1 by root 2, it will be 1 by 2. Then it means the magnitude of this one will be 1 by root 2. We find the magnitude. Then phase, simply in a multiplication angle will be added. Then if you get 1 to 90 degree, then it should be a 45 degree. This will be also 45 degree in positive way. Then you will get the angle. Magnitude is here, theta it will be 45 degree for each. Then our system is HS is equal to B divided by F S plus A, where the magnitude of this one is half 1 by root 2, sorry, and angle of HS it will be 45 degree. Someone is asking something. In sinusoidal PWM and space vector PWM, what type of harmonics present? Odd harmonics except triple harmonics. No, in sinusoidal PWM, if you draw this one, it will be odd harmonics is there. Even harmonics is eliminated because of the Fourier transform. You do the Fourier analysis in a voltage or finding the voltage in an inverter. Inverter voltage you know about. Yes, this will be like that, na. Then to find this one fundamental of this system, you need to do the Fourier analysis of this one. Because of both system is symmetric, you know about the half wave symmetry. This signal is half wave symmetry. In half wave symmetry, the odd even signal is eliminated directly. You will get only the odd signal. This is the because of this is the odd symmetric, not even. Odd even, no, if you multiply of this one even, simple odd even signal like simple I've taken a sine and cos. Suppose sine t and cos t. For checking the odd even signal, then multiply a t at a place of t, take minus t, and what happen this one. Sine of minus t, it will be a g minus of sine t, and for cos of minus t, it will be a cos t, and this will be the even signal, this will be the odd signal. If for minus t, it represents the minus of t. We opposite change the sign in time, then system also change. Same thing here. This is the t axis, is the magnitude axis, time and magnitude. I can say this is y. in y signal. If you multiply up t minus t, then it will be goes to negative. Then it will be not same. That's why it will be in half wave symmetry, but even signal, odd signal, not even signal. In odd signal and half wave symmetry, put the who can learn in signal system. Okay. This is a signal system. In half wave symmetry, in Fourier analysis, we get the or even signal is eliminated directly. Both are question you can check from the Fourier analysis of a voltage signal, because of the voltage signal is like that only in pulses, DC pulses, not a sinusoidal, not on other signal, it is simply pulses, square wave known as DC pulses. Then for finding the harmonics, you should use the you have to use the Fourier analysis. Then you will get the harmonics. And in space vector modulation, if you try this one, then this will be because of the using three phase system, third harmonics, multiplication of third are so eliminated. It means same thing, odd harmonics except the triple harmonics. Okay. Next question is same switches. This is not both are same switches usually. This was vector and sinusoidal PWM. Switches depending on the phases, not technique of a modulation. Now, what should be the value of VDC for generating the three phase AC? No, this is depending on the magnitude of AC, how much voltage you want to generate. Root 3 by 2. Who can generate this one? So, you can find the RMS value of output signal, then you simply find the VDC. Oh, question 6, BOSP transfer function of okay. What should be the value of VDC generated 3 phase signal if 230-volt AC system? You can calculate by simply this is a 3 phase system. Then you simply first find the signal, then find this RMS value of that one. Then after you can calculate the SDC signal. The SP12 triple is eliminated depending on the phase, not simply in PWM technique. This is a three phase system, then triple is also eliminated. Okay, comes with this question. Then you need the magnitude of half of root 2 and angle of 45 degree. Then how calculate the magnitude of this signal? You know about the Hs in replaced in by j omega. Then this will be j omega plus a magnitude of this one. B, this will be a square of root square plus a square. This will be 1 by root 2 given in the question. In the question by the question, you can find this one. Then square the both side. This will be b square divided by f omega square plus a square is equal to half. The question asking about the a value, then find the a from here. 2b square is equal to omega square minus of a square, plus a square. A square is equal to 2b square minus of omega square. First, if you want to find the b, then you should calculate first. If you want to a, then first calculate the b also. Frequency is given 48 Then you can use find omega is 2 pi f, 2 into pi 3.14 into frequency of 48, and you get the omega value. It will be a 3 not 1.44. It will be radian per second. Okay, first equation. Second you can find from a angle of this one. What is the angle of this one? Is equal to b divided by of j omega plus a. Suppose if you have a system a plus jb, then what is means? Both are replaced by your 90 degree. Simple, you can say this is the a, this is the b. Angle of this one is theta. B replaced by the b replaced by 90 degree because of j represent the 90 degree. Then which one you can find the perpendicular to and base in which trigonometry? I think tan theta it means b by a. Then what is the angle? And angle will be a tan inverse of b by a. Same thing you can apply here. B angle is 0 because of there is not imaginary part. So you can say this will be 0 j omega. Then tan inverse angle tan inverse, and say tan inverse of j omega 0 by b divided by of tan inverse theta to tan inverse b by a. B is omega by a. Okay, this angle is given as a 45 degree. Tan inverse 0 by b, it means 0 by b is 0. Tan inverse 0, which means tan 0, tan 0 value is 0. You can use I think angle also. This will be a 0 degree. Then this angle is a tan inverse omega by a. In an angle, in if you want to multiplication of the angle in my then angle will be added in multiplication, and in division angle will be subtracted. Subtracted 0 minus this one, it will be negative. In the question you need the 90 degree of phase shift. Minus 45, it will be the same one, you can say 90 degree phase shift. You can take a negative also minus negative degree 90 degree, then it will also cancel out, and tan 45 degree is equal to omega by a, and this will be 1. Omega is equal to a. Then if a is equal to omega is 3 not 1.44. Okay, from the angle you can calculate the a value. Same thing for v. Can calculate v from here. 2b square is equal to omega square plus a square. Omega square, omega and a is equal, then 2b square is equal to 2a square, then b by a, it will be same 301.44. A and b. Then what is the transfer function? Hs is equal to 301.44 divided by f s plus 301.44. The degree. No, 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 no. This is the not radians. So can't we say directly? Omega is not a radian. Omega is radian per second. It will be frequency, and the A also frequency. A is a frequency, not a radian. It will be radian per second. Then it will be same thing. Yeah, same B also radian, not a radian. Radian per second, because it denoted the frequency, not angle. There is no at angle. It will be frequency, divided frequency in transfer function. You know about second order transfer function. It will be omega n square divided by of s square plus 2 zeta omega ns plus omega n square. Then this is the frequency. All of the depend the frequency. This is the damping factor. This depend the frequency. Then same thing here also. This is the frequency. That's why I've taken a is here in a omega between the frequency. Okay. If the following are the transformer specification, when transferred to primary side, find out the impedance in ohms of the circuit when referred to primary side and secondary side is sorted. Okay. Asking about the transformer. Simple. Use the transformer. Have leakage is given. Primary winding resistance is given. Leakage inductance is given. And refer to primary side. Then there is a mag ah, it's a simple circuit. R1, J X1, J X2, R2. This was the magnitude is given of magnetizing inductor. You can say XM. Because LM is given. Because LM you can calculate the XM. If you want to find this, it means 2 pi FL. Then X1 is L1 is given 2.6 millihenry. 2 pi f is for the 50 hertz. It will be 314 into 2.6 into 10 to power of minus 3 millihenry. Then X1 will be a 0.816 ohm. Same thing for X2, omega L2 say it will be given as the LS leakage 2.6 millihenry. I think both are same. Then both are same impedance 0.816. And XM given 0.5 Henry. Then 314 into 0.5, it will be 157 in ohm. What is the impedance? If you see in from the input side, this will connected in series 1 plus j xl x1 plus this thing all connected to series to this one plus, and both are connected in parallel. That means R2 plus j x2 connected to parallel to the j of xl. If you solve this one, then we will get the impedance. For the parallel circuit, multiplication of Z1 Z2 divided by Z1 plus Z2, then R2 plus j of x2 into j of xm divided by R2 plus j of x2 plus j of xm. If multiply of this one, then R2 will become a imaginary part j R2 xm. Multiply by this one, it will be negative j square it will be minus 1 x2 xm divided by R2 plus j of x2 plus xm. Okay, put the value of all of things, then calculate the final answer. R1 it will be R1 is given in this course. R1 is I think I see. Okay, R1 is RP 2 ohm, R2 also 2 ohm, RS 2 plus J X1 X1 0.816 plus JR2 is 2 into XM is 157 minus of X2 0.816 into XM 157 where R2 is 2 plus J 157 plus XM plus X2. You have to solve this one. From calculator you can solve easily, and if you want to solve by hand, then you need to convert this one a plus jb to in this form mod of this one at angle of something, mod of root of a square plus b square. In this same thing here also apply. Then after you directly divide by the magnitude to magnitude, and at angle places you can subtract. Want to calculate this one in polar form, minus 0.816 into 157 plus of j it will be a 339.12 at angle of 112.19 degree, divided by f, same thing you can apply. This will be 157.82 at angle of 89 degree. So simply divide by this one and subtract the angle. 2 plus j 0.816 plus 339.12 divided by up 157.82, again it will be 2.148 at angle of 112.19 minus of 89.27. Then it will be expand this one in again a plus j form, a plus jb form, to add from this one. This will be 1.978 plus 0. J 0.83. You can add imaginary part and real part. 3.0978 plus j, and it will be comes to the same. It will be calculation sum 0.816 and 0.816. 1 minus 6 5 2. Then is asking about the magnitude. The magnitude of this one, this will be 4.3 is the magnitude, and angle of this one is 22.55 degree. Okay. Something asks like that. How to expand the polar? It is like a 2.8148 into cos 22. Same thing. You put the value of cos 22.92 angle, then you find the value numeric. Then you simply multiply 2.148. Then it will again 2 plus j fifth. Yeah, same thing. You can you find this one, then you can go there. If you find this one, mod of z is equal to 4.3 at angle of 22.55, or at angle theta you can replace this one, or cos theta plus j, or sin theta. Same thing, this one represent as e cos j theta. This will represent only angle. It's also known as polar form. The angle representation is j theta, where this is the angle. Okay, in the same question, impedance in ohm and the secondary side is open circuit. The same question thing. If this will be open circuit, then current is not flowing here. Then simple. These are the in series connection. Then Z in is equal to R1 plus J X1 plus J XM. R1 2 J 0.816 plus J 157. 2 plus J 157.816. It's asking about the magnitude. Magnitude is this one. What object in this condition 157.82. Okay. Given the P dq form is K Vi dq be defined in VQ domain, and P ABC is VA V ABC ABC. Then what is the value of K in conversion of the power? In simple way, I written this one. PABC is VA IA plus VB IB plus VC into IC. Can written this one in the matrix VA VB and VC. In IA is IA IB and IC. Because 1 cross 3, this will be 3 cross 1. You can multiply of this one. So the 1 cross 1 BA IB BA IA BB IB BC IC. Same thing if I do the transpose of this one BABC, then we will get the VA VB VC transpose A IA IB and IC. To reduce the calculation, I rated this one like that VABC into IABC. And you know, for the conversion of VA VB VC in DQ form, this will be a cos theta, this will be minus of sin theta. So cos theta minus 2 pi by 3. Same thing, this will be this is not a cos, this will be a sin. This will be a cos theta plus 2 pi by 3. So will be minus of sine theta plus 2 pi by 3. Suppose you taken this one as a matrix, then B A B C, you can say this will be A into B D Q. Something can do for the current, then of multiply by both to each other. Then we get the final answer. For the IABC, you can know IABC same thing. It will be A into IDQ. But you know we want to ABC, B ABC transpose because of this one. Then you know about multiplication of transpose A into B DQ transpose. It will be same ABC A into IDQ transpose are this one B DQ transpose into A transpose, because no AB transpose is equal to B transpose into A transpose. Now PABC is equal to BABC transpose into IABC. Then you can convert BDQ transpose into A transpose into A into IDQ. VDQ transpose is VD in VQ, like that. A transpose is transpose of this one. Cos theta cos is there, sine is there. Cos portion is upper side. It will be a cos theta cos of theta minus 2 pi by 3 and cos of theta plus 2 pi by 3 minus of sine theta minus of sine theta minus 2 pi by 3 minus of sine theta plus 2 pi by 3. This one follow A transpose, then A same thing. This will be a 2 cos, another is 3 cos 2. Cos theta minus 2 pi by 3 cos theta plus 2 pi by 3 minus of sine theta theta plus 2 pi by 3. Then IDQ, ID, IQ, like that. To solve this one, simply you can multiply by this one cos square theta, collect all of the at a place. Same thing, sin second thing sine is Okay, first cos multiply by this one, cos theta, it will be cos square theta. Again, we multiply by cos sine and cos theta. Then if you sum up this one, sine cos, then we will get this one is 3 by 2, maximum of this one. Opposite of this one is sine cos multiplication, it will be 0. Same thing, opposite multiplication, it will be 0. Because if you added this one, two signal, VA plus VC plus VE, you know about VA plus VB plus VC, it will be 0. But here is cos square theta, cos square theta. If you add this one, cos square theta plus cos square theta minus 2 pi by 3 plus cos square theta plus 2 pi by 3. Then you know about cos square theta, cos 2 theta is equal to 2 cos square theta minus 1. Then cos square theta is equal to 1 plus 2 cos theta divided by f 2. It means half is there, half is there, half is there. Only cos theta is there, 2 cos theta. Sorry, not 2 here. This will be a cos 2 theta. If you multiply of this one theta, there is no matter in frequency. And if you add this one cos of 2 theta, cos of 2 theta minus 2 pi by 3, same thing cos theta plus 2 pi by 3. If you add this one, then the same thing, result will be 0. Only 1 by 2, 1 by 2, 1 by 2 is getting in the answer. That's why it will be a 3 by 2. Same thing is there is a sine cos multiplication. In sine cos multiplication, like sine theta into cos theta multiplied by 2 divided by 2, then we will get the 1 by 2 sine 2 theta. The negative is there, then will be a opposite sign is cancelled out. And this will be also 3 by 2. If you multiply of this one, you can say if 3 by 2 is common, then this will be the identity matrix. Identity matrix we multiply a VD and VQ, then it will be same VD and VQ and ID IQ. Then it will be a 3 by 2 VD ID and VQ IQ. Then K is equal to 3 by 2 or equal to 1.5. This is the too long. If you want to calculate same thing, just written BDQ IQ. The angle difference between this, if suppose theta, and power you know about 3 phase power 3 VI cos phi. Then if you take a if you want to take a peak value, then VPM divided by root 2 IM divided by root 2 into a cos phi or cos theta between them I and V. Phi if we want to take a theta, then theta. Then 3 by 2 magnitude of VM voltage and magnitude of VDQ Same if the Q value is 0, then Vd, if magnitude of both if you taken, then it will be same magnitude of the voltage also. Then you can say this will be the magnitude of dq, this will be magnitude of the iq dq into cos phi. If you convert this one in the vector form, then this will be v dq vector into I dq vector. Vector it means Vd Id plus Vq Iq. Something 3 by 2 is of course. Okay. Last, last. Oh, there's the stress vector modulation technique questions. I'll take one question. This one. Sampling duration is given. Time Ts is 1 millisecond. Ta is given 0.9 millisecond. Tb is 0.2 millisecond, and Tc is equal to 0.4 millisecond. And what will be the timing duration? Effective time duration, it means how much it will turn on and off. Now you know time effective time, it will be a time of maximum minus a minimum time. Then you can say this will be the effective time. The maximum is which one? Maximum is 9, 0.9 minus 0.2, 0.7 millisecond. Same thing, time duration for zero vector T naught. Then simple, T naught is total time minus of effective time. 1 minus 0.7, that will be 0.3 millisecond. Then offset node minimum time plus half of the zero vector. Then minimum time is given 0.2 plus 0.15 is totally 0.05 millisecond. Okay, same thing, T offset is also in the question. Okay, everyone, I want to stop here. Remaining question and some revision question is of the subject I will present day after tomorrow, I think 17 October, Thursday. That one is I think our last lecture uh, from my side. Okay, this is the today is 15, 17 is the next lecture, and I think last lecture. Okay, thank you to all.